Compression so far only, right? So compression is only one part of the problem. Okay, in order to do good communications, you need two parts, right? You need good compression so that the file size is small. That's obvious. The bandwidth is low, but you also need the actual communication part, right? How do you actually send those information over? How do you send a bit stream over? So today we take a quick look at communications of images and video over our very popular communication channels. Okay, so we have several popular communication channels. Right? We can have a dedicated line. We can have the internet protocol, the IP networks. Okay, or we can have a wireless communication. Okay, and obviously we're working with images and video. It's a lot more data intensive, right? Bandwidth requirement is a lot larger than your regular email, right? Communication of an email or text is pretty easy to do, okay? But communications of huge images and video files or sequences or streams are not so easy to do, okay? And it turns out that, so with one basic, we already have a problem. Voice over IP works pretty well, but it takes a long time for voice over IP to really establish itself. And the idea has been around for ages, but it takes a long time for people to figure out all the details, make sure that the system works the way it is, and then introduce to the market. Now voice over IP becomes a very popular tool, so a very low cost, effective solution for voice communication, right? And hopefully we would like to do the same thing with images and video. But so it gives you an idea that in order to do this, you're not going to see the result immediately. It's going to take some time, okay, for it to happen. But the key is we position ourselves in such a way so that when it's ready for prime time, we're right there in the middle of it, right? That's it. We'll talk a little bit about network multimedia. We'll talk quickly about some of the network types and examples. And we focus on IP networks. It's very popular nowadays. And so we're going to use the internet, the IP setup, internet protocol networks to transmit these images and videos. We talk a little bit about source versus channel coding. Okay, this is the protection of velocity communication channels. And if we have time, we will spend a lot of time on error resilience. Because that's the entire idea. Okay, most of the communications channels that we have, especially with images and video, we cannot afford to sit there and wait. Okay, most likely we just have to move on with losses and hopefully try to cover up our error as much as possible. Okay. Now, so the internet has many different modules. We can have major enterprise, like large companies and governments do it. There are small businesses, telecommuters using wireless cell phones. There will be home offices, consumers using ADSL, cable modem, PSTN, dial-up service. Okay. So there are many different types of classes of users sharing the same big block that we call the internet, all the fiber optics cables connections that lay down in the ground. Okay. Now, what are the considerations for multimedia? So this is the difference between multimedia communications and email communications, or text and HTML communications. Right? We need some degree of error resilience. Okay. We have a lot of redundancies in the images and videos, so hopefully we'll be able to take advantage of that. Okay, with text and emails, it's harder to have that type of correlation. Okay, so there are a lot of these error resilience techniques seem to work much better with visual data rather than with text data. The bandwidth requirements is huge. Okay, so that's another difference. We will have to struggle with two types of bandwidth requirements: the constant bitrate requirement and the variable bitrate requirement. For video, which one do you think is better? Should we do constant bitrate or should we do variable bitrate? Variable bitrate, right? Why? Our video frames are not uniformly distributed in any sense, right? Sometimes we don't have motions, so the bitrate will be low. Sometimes we have a lot of motion, the bitrate will be high. And if we insist on doing constant bit rates, like the HTML, the text communications, we wouldn't be able to deliver constant quality, right? We just have to sacrifice quality for bit rate. And that's not what we want to do. We want to watch videos with relatively constant quality. We don't want the flickering effect, right? So, and there's a problem between symmetrical and asymmetrical, meaning should we make both encoder decoder having the same complexity or different complexity? So obviously, we are sitting right here because our decoder are typically having a lot lower complexity than the encoder. Okay? For most practical cases, that is good. Okay? But as we mentioned yesterday with distributed coding, there's some setup that maybe you want a symmetrical setup. Okay? Now the quality of service is another problem. We have to make sure. Okay? So these are the type of errors that would affect the quality of service. Okay? So you will have delay in the network, you have packet loss in the network, you have bit error rates. So most of the time when you guys work with channel coding, we are concerned about bit error rates. Okay? But there's one more level up. It's the packet loss level. You're losing busty type of loss. That you lose the entire chunk of data rather than losing 1 or 2 bits. Okay, so that is the type of the packet loss and the delay jitter give you the bus error rate, the bus error length that we also have to worry about. One more, real-time constraints. In video, we have to keep up with the frame rates. Okay, if you set up with 15 frames per second, 24 frames per second, you have to try your best to keep up with the real-time constraint. Okay? Nobody wants to stop in the middle of the video and say, okay, we're going to take a break. Okay? When I'm paying, as a paying customer, I click on a button to watch something over the web. I demand to watch the video from beginning to end without any interruption. Okay? It's a different course. Okay? We don't have time to attack that problem yet. Okay? And finally, as engineers, we are very worried about cost all the time. Okay? We're very conscious about the cost of the system, the cost of implementation, the cost of deployment. Okay? So let's trace back and take a look at what type of networks is available to us if we want to communicate image and video over a certain communication channel. Okay. So the first type of networks that becomes very popular is circuit switch network. Okay. The principle is this: several connections are time multiplexed over one link. Okay. And a dedicated circuit is established during the complete durations of the connection. So this is basically our old telephone network. This is how we communicate with the regular telephone, landline telephone. Okay? When somebody pick up the phone, dial the numbers, okay, it will set up a